Before we solve this, let's make sure we have our facts straight. We have the digits 2, 4, 6, and 9, and from these four digits, we're going to create two different two-digit integers, and we want them to be as close as possible to one another. We want them to have the least possible positive difference. I think there are a couple ways we can go about solving this question. For example, one thing we could do here would simply be trial and error. We could try to guess the numbers that are as close as possible to one another. However, that's not a very efficient approach, especially when there's so many options like there are here. I think a very simple approach that doesn't require trial and error is simply to jot down the possibilities. For example, if we have these four digits, what sort of two-digit integers can we make? We can make 24 and 26 and 29. And of course, 42, 46, and 49. 62, 64, and 69. 92, 94, 96. Those are the numbers we can make. And now that we've jotted them down, let's look at their differences. We have the differences 2, 3, 13, 4, 5, and 23. And of these, the only one that's a potential answer choice would be 13, right? That is one easy guaranteed way for us to know that 13 has to be the correct answer. If you're wondering why we don't have differences such as 2, 3, 4, or 5 in the answer choices, look back to our differences. The difference between 24 and 26 is 2, but remember, we need to use each one of our four digits once. Here we're using the 2 twice, and we're not using the 9 at all. And likewise, in the case of 26 and 29, where the difference is 3, again, notice how we're using the 2 twice, but we're not using the 4 at all. In other words, differences such as 2, 3, 4, and 5 are not among the answer choices because they only occur when we double use one of the digits and not use all four of them. And there you go. That's one reason why here 13 is the correct answer.